This is a solar-powered SHaCK solar heat bank alternative community kitchen. The idea is that it uses a variety of energy sources. In this case, it's solar PV, and it creates heat through resistive heaters. Most importantly, it stores the heat in a heat bank. In this case, it is soil, mainly clay and a little bit of sand. And then that stores the heat, so in the future, today, tomorrow, and 2 days, we can use that heat that was collected today to cook in the future. So the solar panels connect to these resistive heaters. These are resistive heaters that are available anywhere in the world. They're used for the electric cooktops. So we put them in tubes so they can be easily removed if they fail. The SHaCK is designed to have a 20-year operating life, so it is likely over 20 years. Some of these will fail, but they're easy to replace. So there's 1, 2, 3, 4, 5, 6. And then the SHaCK is very important for the insulation. This is a minimal amount of insulation. It really should be all the way out to these posts, all the way around, to retain the heat. At that point, about 5% of the heat would be lost per day. In this configuration where the heat bank is exposed, it's probably losing 30% of its heat, 40% of the heat per day. Well, actually more than that, probably 50% of the heat per day. So this is about a little bit like 3/4 of a cubic meter of dirt, and it would be sufficient when up and running to feed, probably prepare 80 meals per day, maybe 100 depending on the type of food you're preparing. So the energy goes in the resistive heaters when the sun is shining, or other ways to make heat. This system is also set up for a pyrolysis reactor. So it's another way to generate heat is through pyrolysis of biomass. We'll demonstrate that in a future video. And then the system, the heat comes out of this system, and we use water to do that. A very simple little pumps ambient temperature water through a tube all the way up to the top, comes back down, and it ultimately comes out here. There's 50 meters of 1/4 inch 6 millimeter tube inside this heat bank, and then a pressure meter, a pressure relief valve just for safety, and then valves into each of the 3 cookers. The 3 cookers use frying, deep fat frying, and boiling. And the key to these is that inside are coils of aluminum tube, and then wax. Wax is for efficient and maximum surface area coverage and heat transfer. We add graphite to the wax to improve its heat transfer capability by 10x. And then after it's all done, we collect the condensate in this condensate collector, and then we can collect the hot water at that point and put it back into the pump and recirculate for maximum efficiency. In production, this system would be higher for the cook's benefit, plus all this would be covered up to retain the heat as well as for safety reasons.